For my space colonization, I've decided to build a station on Titan, Saturn's largest moon. Let's start with what Titan has to offer for humans. According to what has already been discovered on the planet, scientists believe that Titan can fulfill most human needs, such as fuel, water, and other basic needs. One of the most important points to colonizing Titan is that scientists believe there is liquid water beneath parts of the planet that are covered in ice. Water is essential to life, therefore this is one huge factor towards colonization here. Titan is also said to have an abundance of hydrocarbons, much more than what we have on Earth, and this refers to methane and ethane. These can be used in many ways, like heating and electricity, and their atmospheric pressure is also similar to that of Earth's, specifically only 1.5 times greater. The atmospheric pressure is important because humans can only live in specific conditions, and in other places with higher low pressure, they require pressurized suits, so it doesn't negatively impact your body form. In relation to the atmosphere, it also contains the element nitrogen, which is important for plants, and also a major component in our air. One reason why Titan is a better option than Mars or the Moon, for example, is because it produces far less radiation. Unlike these places, Titan can keep a colony safe as it has a very dense atmosphere, which will shield the humans from the solar radiation that comes from the sun. And these radiations are dangerous as they can affect your health as they emit electromagnetic fields, causing health issues. Now, in terms of electricity and heat, my colony will be powered by natural gas, specifically the methane and ethane hydrocarbons from Titan. Firstly, through the combustion of these hydrocarbons, heat energy is produced, so this can be transported through to regulate the temperature, and the rest can be used for the electricity process. Now, due to the temperatures on the moon, the methane is most likely in the form of liquid, so it will have to be placed in a burner and until it becomes a pressurized gas, and then from there we can use it for the electricity process. A turbine connected with a generator is attached to the pressurized gas tube. The gas spins the turbine, which will spin the generator, and the spinning magnets within the generator cause electrons to move from one place to another, and this will generate electricity and can be transported to other areas in the station for use. To reduce the amount of energy lost through heat in the transport process, the electricity will be sent with a high voltage. Higher voltage means that the electricity cannot be efficiently converted into different energy forms, such as heat, and this is due to the decreased resistance. Step-up transformers can be used to increase it during transmission time, and step-down transformers can lower it when it approaches to certain compartments within the station. Now, to generate oxygen, we can use the electrolysis of water process. Since there will be no oxygen on the moon, we need a way to generate some. This process separates hydrogen, gas, and oxygen from the compound of water. And water has been found on Titan, and scientists believe that it's beneath the ice surfaces. Therefore, it can be pumped out for this process and our use. So in electrolysis, electric current passes through a negatively charged cathode to a positively charged anode through water, which will separate the atoms and cause the hydrogen atoms to attract to the cathode and the oxygen atoms to attract to the anode. The hydrogen can be then combined with the carbon dioxide humans breathe out to form more methane for energy, which can be a backup plan for the gas exchange between plants and humans, which we will also speak of after. And the air that we will breathe in the station will have to be combined with the atmospheric nitrogen that the moon also has an abundance of to form Earth-like breathable solution, which basically consists of 78% nitrogen and 22% oxygen. The combustion of methane and ethane uses methane and ethane and oxygen to produce CO2, H2O, and heat energy, like we said earlier. Therefore, once O2 is produced through the electrolysis of water process, some oxygen can be used for breathing, while other can be used for combustion. The combustion process produces carbon dioxide, which can be combined with hydrogen from electrolysis to make methane, or absorbed by plants and converted to O2 through photosynthesis. Water produced can be used for electrolysis, as we can use water straight from the moon of Titan for our own purposes, or vice versa. This is almost like a cycle of its own. In my station, I had the idea to add a second lower floor beneath the floor of human activity filled with just grass. In the grounds of certain areas on the upper floor, there will be little holes, and these holes will allow gas exchange between plants and humans. Humans breathe out CO2 and they breathe in O2, while plants do the opposite and they take in CO2 converted to O2 through photosynthesis. I also found that CO2 is more dense than O2, and this is why the cycle works. Us humans breathe out the CO2, and since the CO2 is more dense than the O2, it'll sink to the bottom floor and it will be absorbed by the plants. The plants will use it for photosynthesis, convert it to O2, and the O2 will rise once again. This cycle will continue to purify our air. The plants will be given automatic watering and artificial light to continue to grow and stay healthy. When grasses begin to grow too much, they can be cut, and leaving the clippings on the grass provides it with its own nutrients as well. This may or may not work, but the nitrogen released by these plants due to the nitrogen cycle may be used to fulfill the 78% of nitrogen that we are meant to have in our air. This will only work if we have access to denitrification bacteria, and specific calculations will have to be made to make sure that the amount of nitrogen and oxygen released from the plants are maintained at the correct ratio of air that the humans breathe in. If we don't have access to the bacteria, we can use the nitrogen directly from the atmosphere of Titan to complete the solution. In my station, NTB conditions will be used, which are 20 degrees Celsius for temperature and 1 atm for pressure. These are normal conditions for humans and plants to live on Earth. The density of CO2 and O2 combined with the pressure and temperature conditions on Earth should make this gas exchange possible. This is why I'm simulating these same conditions in my dome so that the human and plants can live and gas exchange should work. However, I couldn't find much on the effects of gravity on this exchange. Gravity on Titan is only 14% of what it is on Earth, but I believe that the NTP conditions should be enough to allow it to continue to work. In terms of crops, pollination will need to be considered. Pollination is a process that makes seeds for the plants to reproduce, and in this process, pollen grains are transferred from different plant parts to produce seeds. In terms of farming, self-pollinating crops will be the best ones to use as they don't require the help of pollinators like bees, and some self-pollinating plants that I'd consider planting on my colony include legumes, peppers, greens, rice, wheat, and more. If my colony will be all vegan, self-pollinated crops will be more relied on as cross-pollination requires bees or other animals, and the apex predators will need to be regulated. One way that those predator populations could be controlled is by self-regulation, which some species can do, but not all. Bees can also be brought to the station to pollinate other crops in need of them that cannot self-pollinate. This is called cross-pollination. If the bees are brought, the whole food chain will need to be there to regulate the populations of each species. Us humans regulate the plant population. An animal that eats bees will regulate them, such as bears. Bears may be able to self-regulate, but if not, they can be eaten by humans. Some crops, such as corn, are wind-pollinated, therefore artificial wind will have to be generated, maybe through fans, to allow the crop to reproduce in its way. Now for plants, soil may be an issue to find, as Titan doesn't seem to have fertile soil for our needs. The effectiveness of methods such as hydroponics and aeroponics will need to be tested. Hydroponics involves using liquid solutions to give plants water and nutrients, and aeroponics is a method that uses a misty air environment to grow plants. Maybe nitrogen and oxygen can be physically bonded to make NO3 nitrates for plants. Another possibility is to make water, nitrogen, and any other nutrients needed available to the plants from their roots, and the plants will uptake their needed amount and use the element individually rather than in the form of nitrates and other nutrients. Titan also has ammonia, which could also be used in the plant processes somehow, and all components that soil possesses will have to be given in different ways so that plants can still grow like they do here on Earth. Now, plants will have to be chosen very carefully as some plants cannot adapt as well as others. Even here on Earth, certain plants cannot live in certain conditions due to their inability to adapt, and that might be another factor to what crops or plants you will choose to plant there. If people on my colony are vegan, that would eliminate the need for a full-on ecosystem with full animals. Now, if people on my colony did eat dairy and meat and aren't vegan, cows can be brought in a separate ecosystem with grass. Cows eat grass and their predators are tigers, which are apex predators. In fact, apex predators can regulate their own populations. The cows can provide milk for the colony. Believe it or not, cow waste is actually methane, which is another source of energy. The grass population is controlled by the cows, the cow population is controlled by the tigers, and the tiger population can be controlled by humans as we can use them for meat. In this ecosystem, the lower the trophic level, the greater your population should begin as. This is because higher trophic levels receive less energy per meal and eat more. Therefore, you should have many more cows than tigers. The grass population will also need to be much more than the cows. The cows need enough energy to continue their lives and reproduce from the grass, and the tigers also need a lot of energy from the cows. The populations will have to be very specifically determined. The ecosystems must be maintained at an equilibrium, equalizing the birth rate to the death rate. The typical age a species lives and the resources it has, like nutrients, food, water, light, etc., are just a few factors to calculate the population needed. The species' individual population must be controlled as well as the overall ecosystem's population. In my station, I'll have a wastewater compartment, which will clean the water for our reuse, and this can be done through a water filtration process. A machine will start by filtering large unwanted particles like debris. Then it'll run through filtration beds that'll remove impurities, and finally, we'll use an oxidation process that uses chemical reactions to kill bacteria. Used water will be sent to this compartment and then transported back to where they're needed after. Now, in terms of water usage, cloths will be needed to be damped to use for showering purposes, and for drinking, it'll be put under high pressure and have an automatic mechanism that will collect the water into bottles. The space station will be made of some insulating material from the inside to prevent the heat from escaping, and from the outside it will be made of some kind of metal conductor, as it's more solid and can easily be shaped. Therefore, to prevent any accidental power surge, in case the electrical current somehow comes in contact with the outer layer of the building is already touching the ground, which will neutralize it. Power outlets will also need a ground wire, which will be connected to the ground to protect high voltage appliances, which will be used within the station. Items could be burned for disposal of garbage, and actually any greenhouse emissions could also be an advantage on the moon of Titan, and this is because it has a dense atmosphere and it'll have a similar greenhouse effect to the Earth. So releasing greenhouse emissions could actually allow the moon to heat up over time. It's an unlikely idea, but maybe years and years down the road, it could become habitable for humans temperature-wise. One issue is that renewable energy sources will be difficult to use on the moon of Titan. Of course, methane is a non-renewable energy source, so this will be depleted over time. But solar power will not be able to be created because it's very far from the sun. Wind power will also not be able to be generated because a wind speed of 0.3 meters a second was actually recorded by a NASA Voyager spacecraft on Titan. And the only possibility is hydropower, which can be brought in the building, melted, and somehow manually moved in a way so it produces electricity by spinning a generator. As mentioned earlier, another issue is soil, and hydroponics and aeroponics will have to be alternatives for that. I also think in case of sicknesses, proper medical equipment and experts will be needed. Special herbs may have to be grown to produce remedies, as medicines may not be possible. Next, we'll be looking at a model of my living quarters. Here I have a model of my living quarters. So as you can see, in the top floor we have a toilet, a sink, and on the top you can see LED lights. And we have the bed, we have a few outlets, a light switch which will control all the lights on the upper floor, a TV, a vent, and a microwave. On the bottom floor we have a layer of grass with a vent, a few fans to allow the grass to wind pollinate, and some lights on top. And over here we have a ground with holes in them to allow the gas exchange between humans and plants. Over here you can see that each black pipeline connects to the vents, which will connect to the heat generation compartment, and each electrical appliance is represented with a white pipe cleaner and will all lead over to the electricity generation compartment. And the two items that need water, such as the sink and the toilet, are connected to the water generation compartment. Next, we'll be looking at what my electrical circuit diagram for my module would look like. When I mention a circuit diagram photo, it's a photo that I took of my circuit diagram sheet a while ago, which was then updated from the video. Now I do not have that, therefore please ignore any text pop-ups. Here's a circuit diagram of my living quarters. Here I have 15 amp 7.3 ohm outlets, 5 of them, and they're all in parallel. On the next branch I have 1.5 amp 73.3 ohm lights, which are also all in parallel, with a switch right here which will completely turn on or shut off all the lights at once on only the upper floor. In the middle branch I have the alternating current generation, and right next to it I have the circuit breaker switch for the complete room, which will trip if it has over 110 volts or 85.8 amps. On the lower floor we have the exact same light fixture as the upper floor, which has 3 lights in parallel with 1.5 amps each and 73.3 ohms of resistance, and a switch, of course, which will control all 3 of these at once. And on the final branch we have these motors, which will actually be used as fans for the grass, and these are each 0.6 amps, 183.3 ohms each fan, and these are the fans for the grass wind pollination. Over here we have the calculations which divide the voltage by the current to find the resistance of each item. And then over here, the circuit breaker will switch off if voltage exceeds 110 volts or if current exceeds 85.8 amps. As you can see, I've wired my circuit diagram in parallel, and this is because, first of all, the voltage stays the same in a parallel circuit, and second of all, parallel circuits have multiple pathways, which means that if one load breaks, then the other loads will not necessarily be affected. And in terms of current, it does get divided, but in a solution for this, what I did was I increased the resistance of the loads, so the current passing through each load would be at the standards that it needs to be. The voltage remaining the same throughout in this parallel circuit was important because most appliances and items use voltages between 110 and 120. Therefore, since it's the same in parallel, it would also be convenient since they all use around the same voltage. Thank you for listening to my ideas on building a space station to support a human colony. I hope you've gained some insight on the moon of Titan as well as all the living factors that I've considered.